and then you just pick the largest one. This is not different from what softmax does, so from what is traditionally done. So this argmax step is the way classification is done normally with softmax. You have your softmax output, and then you take the maximum activation.
Just add a new class. So
You just,
two classes, you're gonna have a choice. Red, black, or unknown.
Then, maybe I'm barking up the wrong tree. How is that unknown stored in the configuration of the storage?
What storage? What are you?
The machine must hold that configuration of an unknown as an expression in code.
No, it's just the output of the layer. You're constructing the layer instead of the layer being just. So this is the softmax. So that's what softmax does. So you get the penultimate layer, and then you have the softmax layer. What you're doing is, instead of putting the softmax layer, you do that, you calculate the y-Boult distributions, you renormalize, and then do the classification. That doesn't, like, this is going to be your output layer.
I think this question is like, if you have a set number of classes, do you have to add, like, is there a real additional node in the final layer, in the output layer, or is there like an artificial layer, an artificial node has it?
Well, the output, so the OpenMax output, if your softmax output is 7, then your OpenMax output is going to be 8. They put it here in their examples. They were using 1,000 classification classes for softmax, and then OpenMax has 1,001 classification outputs, which is unknown.
Yeah, I'm just curious, why do you think they require a mean mu j? I don't see anywhere.
That one, that is the mean value for each of the activation.
Yeah, but I don't see it's being used in the algorithm.
It's in here.
Oh, it's in there.
Yes, because you calculate the y-Boult distribution of the distance from the mean.
Oh, okay.
So it's when doing this step, you need to use the mean value to see where your example falls.
So this x is
Yes, x is
a
like
function of the mean and the input.
Would it be in principle possible to do this also in the pre-penultimate layer? Because this seems to be like you're looking for a signature of your class in a layer, but it doesn't have to be necessarily the penultimate.
Yes. So in the beginning of the paper, they give an argument of why it is the penultimate layer, and it's based on previous research that shows that while the softmax output just is trying to convert this layer into a probability distribution, that layer differs between, so these activations are significantly different when you have different classification classes. And it follows a y-Boult distribution and so on, so it has all these properties that they need to build the algorithm.
Do they provide any guidance as to what epsilon should be?
Yes, they say grid search.
Okay.
So yeah, you have several parameters here. So of course you have epsilon, which is your threshold for uncertainty thresholding. You have eta, which is the maximum value which you're going to try to fit to, and you have alpha, the number of top classes. So yeah, what they do is a grid search calibration procedure, trying to optimize an F-score of classification. And well, they also argue that well, they didn't show that in the experiment, but they argue that it's like a corollary of their work.
When they do the F-score, how do they treat the extra layer?
It's the output.
Yeah.
So instead of using softmax,
But the last one doesn't have a layer, right?
yes,
The
it
zero.
provides it provides a classification. Oh, that one.
Yeah.
Yeah,
Just-
those are
just skip
rejected.
it.
No, because so in their training sets when they're comparing,
Yeah.
they compare to softmax outputs that have been thresholded. So for
Threshold.
uncertainty, for uncertainty. So how many outputs from softmax are rejected? So softmax can reject by uncertainty thresholding.
Ah, I see.
So you can say I'm only going to keep softmax outputs that are above this epsilon,
Yeah.
which is this exact same thing.
So then why do you need the extra layer? You can just use the threshold and then say if
Yeah.
you're
So
outside, just use the threshold.
yeah, it's so in the results they provide all the justification for that, and it's because of the different types of.
It's because you weight the individual distributions of the.
So the softmax isn't actually predicting all the classes that are outside. It's just trying to give an estimate of the classes that it knows, right? So for instance, this is a fooling image for baseball, which was artificially constructed to give a high softmax output. So softmax gives one probability that that is baseball.
One.
Yeah, so it's just one class.
Yeah.
Whereas OpenMax gives it 0, because it finds in the. So I find this a very convoluted image, but
Yeah.
well, once you stare at it for like 20 minutes, you start to understand what it is. So these are examples. So the x-axis are examples in the image dataset. These are the activations. So each vertical column is each column is the activations for that example, the activation vector. So this penultimate activation vector, and then they show it for different things. So I never understood what this model was.
I think
think
model
it's
is
exam, right?
no. I think model is the vector of means.
The vector of the means.
You
Okay.
have you.
Yeah. Okay.
Yeah.
So that's the mean value, and what they show is that, for example, for sharks, so this is the mean activation vector. The fooling set has high activation on softmax, and in the open set it doesn't have high activation. Okay, so that's how they argue that they can reject.
How
So-
do they construct the fooling set?
The fooling set is constructed manually. So
they come
so
up
these
with
are.
how big is it? I'm just curious.
I don't
Did
know.
they just construct a few images to show that they are
So,
better?
yeah, so this data set is the image specification. Where is it? So it is a data set that contains these examples, but they are
Did they create it themselves?
no, they are already in the data set.
Okay, good.
But these they have been engineered to produce high softmax activations.
Yeah, but the authors did not create them.
No,
Okay.
No.
That's
and yeah, the other interesting things are, for example, these rocks. They're supposed to look like baseball, so they're like fooling examples for baseball. Even so, softmax gives no, that's open set. It's supposed to be low score, low probability, and it does give low probabilities. Okay. Same here, 0.25, and this one gives even lower probability. So that is not a shark; it's a dead fish on a beach. Yeah. So those are a bit the main results of the paper. The other interesting results, which has more to do with what you were asking, is this one. So again, very convoluted image. But the red dots are rather fooling, so triangle. So you have triangle, open set, and validation, and then ImageNet 2012 is the data set. And then the more off diagonal is that OpenMax out of the probabilities, So if that is softmax, if that is softmax and that is OpenMax, then these are where the probabilities were significantly different, and you can see that it was mostly on fooling images. So fooling images have very altered probability by OpenMax, where softmax would have put them here. And in the in the open set as well. Okay, but it's mainly against fooling images. They say that doing yes.
No, I'll wait till
Okay, so they say that